This video is my second example of an improper integral. I'm going to try to compute this integral. I assume you have watched the previous video in which I define improper integral and explain how to compute them. If so, I invite you to pause this video, try to calculate this, and then continue watching. In this second example, I want to calculate the integral from 0 to infinity of the function x over x squared plus 1 with respect to x. This is an improper integral because infinity as one of the extremes of integration. It's not a number. Geometrically, this integral represents this area between the x-axis and the curve from 0, and it keeps going all the way to infinity. And we know, like in the previous example, that I cannot compute it directly, but I can set it up as a limit. So just like in the previous example, I'm going to calculate the integral between 0 and a bigger number at b of the same function. And then I'm going to calculate the limit as b goes to infinity. So instead of infinity, I put an arbitrary positive number, and then I take the limit as this number goes to infinity. So let's do it. First, compute the integral. Second, take the limit. To compute the integral, I need to find an antiderivative for this function. And perhaps it's clearer if I multiply it and divide by 2. Because now 2x is exactly the derivative of x squared plus 1. And that suggests that I know what an antiderivative of this function is. It will be simply logarithm of x squared plus 1, because its derivative is 1 over x squared plus 1 times 2x from the chain rule. If you don't see this right away, that's okay. You can always do a substitution called u equals x squared plus 1, and that will lead you to the same answer. That's an antiderivative. I need to evaluate at 0, and I need to evaluate at b. Let's do it. And the logarithm of 1 is simply 0. As b diverges to infinity, b squared plus 1 also goes to infinity, and logarithm of that also goes to infinity. So in this case, the limit doesn't exist because it is equal to infinity. Or in other words, this improper integral is divergent. It's peculiar that the function looks very similar to the one in the first example, but in the first example, we saw that the area under the curve going all the way to infinity was finite, was a number pi over 2. In the second example, the area happens to be infinite.